just wanted to follow up on that last problem, just in case there was any doubt. The graph of the piecewise function that you see here in problem number 8 is defined to be the piecewise function f of x equals this stuff here, x plus 3 when x is less than -1, and f of x equals -1 when x is greater than or equal to -1. Okay, and so in problem number 10 we have 3 pieces, and let me zoom out a little bit so we can get a little bit more space down here to work. When we have 3 pieces, we just need to leave space for 3 pieces. And the first piece, say the first piece is defined for the x values x less than -2. Now, we have dots here, we have connecting values, and so we have to determine, we have to just make a decision on which piece we're going to give the endpoints of that interval to. So I figured might as well give the endpoints to that middle piece so we don't have to think about it anymore. But y equals 3 when x is in between -2, including -2, and also including 2. So from -2 to 2, y equals 3. Now, this first line, each one of these is a linear function, the middle one being a constant, but this line would go through the points -2, 3, and -3, 0. So let's find the slope a different way. Let's find the slope by counting up. We're going to count up 1, 2, 3, and we're going to go over 1. So the slope of this line is 3. And then if we go from -2, 3, up 3 and over 1, we're at -1, 6. And then if we go up 3 and over 1 again, we're at 0, 9. So if you followed that, you followed that these lines, if they continued, would actually both have a y-intercept of 9, and you can't see that, but I'm counting up. So each one of these, if you kept going, if you put them on graph paper, it'd be easier to see, but if you kept going, each of these lines would go through the y-axis at y equals 9. The slope of this, the line defined to the left of -2, has a slope of 3. And this line here to the right of positive 2 has a slope of -3. Okay, so it's pretty easy once you get the slope and the y-intercept, because that's how a line is defined in slope-intercept form. So the first piece would have an equation, y equals 3x plus 9, and this piece would have an equation, y equals -3x plus 9. Therefore, we take what's to the right of the equal sign. So here's an equal sign, here's an equal sign here. So to the right of the equal sign, we define the first piece as 3x plus 9 when x is less than -2. We already defined the middle piece. And now we define the third piece as -3x plus 9. And that's for the x values that are greater than +2. And that's the piecewise function defined for the graph that you see here in problem 10. And then the last problem, hopefully the last problem is the easiest of them all, because they're all constants, and so should be the easiest one. So let's go ahead and start from the beginning. We know that there are 3 pieces, so we put 3 commas. The first piece here is defined between 0 and including 0, and 1 and not including 1, all right? So the y-coordinates are a half a unit high. And then the second piece, the y-coordinates are all 3/2 units high, and that piece is defined for the x values between and including 1 and 2, but not including 2. And then the last piece is defined to be 5/2, and on the interval from 2, including 2, to 3, but not including 3. That's not an equals to 3. And that's it. So that should be a pretty easy one, since they're all constant pieces. So each piece of this piecewise function is a constant. And there you have it.